everybody. My name is Jacko Holleran. I'm the CEO of SKALE Labs. We are the core team behind the SKALE network. It is my pleasure to be here today to speak to you about DeFi here for the DeFi Summit. My understanding is we have some DeFi experts here watching. We also have some people who are new to DeFi. So I'm going to talk today and start from a pretty accessible point to talk broadly about DeFi and where DeFi is going, and then talk a little bit about the challenges we're facing in DeFi and the opportunities. Lastly, I'm going to move into discussing scaling and how we can help Ethereum scale and how specifically the SKALE network functions in the realm of DeFi. So without further ado, let's get into it. I'm going to share some slides. All right, here we go. DeFi Summit. It's my belief that the next generation of business, finance, and consumer applications will be powered by hundreds of thousands of connected EVM blockchains. So what does that mean? It doesn't mean we have one blockchain that's helping run business applications and decentralized finance. What it means is we have many, many blockchains all speaking and talking and communicating to one another, just like we have with today's internet. If we look at the way the internet works, the internet is a set of loosely coupled databases, and many of these databases that are all one message away. What they do is they message state and update. So imagine you're taking Uber and a payment happens on the back end through Stripe. The Uber application says the ride's over. Stripe messages the credit card, your bill. You know, these are not in one database. What they are is they're many systems connected, speaking and talking to each other. For DeFi to scale to the next level, we need to get to a point where we do have decentralized finance running not just in one blockchain that's a shared resource, but many blockchains that all speak the same language, i.e. Ethereum. And also I believe that Ethereum will be a base layer to settle and ensure that there is a one source of truth at the end of the day. But in order to get real-time transactions and hundreds of millions of transactions, we need to grow our infrastructure. So let's talk a little bit more about that. Okay, many of you are very new to DeFi, and so I'm going to take a simple approach here discussing this at the onset. So at its core, financial systems are really rooted and supported by lenders and borrowers. What that means is some people want to borrow money, some people have money to lend. And then this mechanism is then what helps drive this entire financial system. And the base of this for the US economy and many global economies are mortgages, you know, just huge homes, mortgages where people are lending and borrowing. It also, you know, we look at savings accounts, we look at other mechanisms for saving. What you're doing is you're actually putting money into this global financial ecosystem where then people are borrowing, and then it boils up into more sophisticated elements around trading and financial assets and company ownership and shares and equities, and in the crypto markets, tokens and token ownership. But really at its core it's all about lending and borrowing. And what's happening today is there's huge value extraction because there's middlemen playing roles and legacy rules and structure and wealth that's created off extracting value out of this dynamic, i.e., you know, enter smart contracts. So again, taking a very simple approach here. But what I want people to take out of this is that throughout many elements of DeFi, smart contracts can come play a role to tie together value between marketplaces, whether it be lenders and borrowers or more sophisticated financial elements. And smart contracts work to really codify rules and input escrows, okay? And so this is where ledgers and blockchain technology comes into play with computation and smart contracts. What this means is we can create a set of rules with open source code that say, if the borrower wants to borrow the money, the lender will give the money. And a smart contract has a set of rules around what the rate of return is, what the rules are for collateralization. And it automates all of this without any dramatic impact from a middleman. Okay, and there's more value that goes to both parties without value going to a value extractor. Okay, and it's not to say that finance is all value extraction, centralized finance. There's a lot of incredibly valuable elements of centralized finance. What I'm saying is decentralized finance has the ability to bring finance to the next level of more equitable value, and also support centralized finance in an augmented and integrated manner, not a purely disruptive manner where the world's run by smart contracts. There's a ton of growth here and a ton of value to be brought to many people through DeFi. Right now, though, we have some big challenges to growth, and many people interact with DeFi through swapping tokens. That's a really great entry point. And we look at the value of Uniswap and other similar products where you can have a token and have ownership in a decentralized network and be able to swap that for other pieces of ownership. And being able to swap Ethereum for SKALE, for example, is an example where DeFi comes into play. Now, the issue with the current version of the way we look and structure blockchains is that we're looking at them as one database. And there's some attractive qualities there when you have one database, such as atomic swaps and real-time composability, but we lose a lot of the values that we have with loosely coupled databases, what we see in the modern internet. And again, Uber ride pinging the Stripe network that pings the bank that then makes a payment happen based off of the logic of I took an Uber or a Lyft halfway across town and it cost me $13, right? And so what the issues with blockchain today is because of the dynamics of having one database, the fees can be incredibly high, the block times can be very slow, which make for issues and value extraction even within a decentralized network. And also, what's happening here is the throughput can be low too. It's like a traffic lane and everybody's in one lane and that lane's moving incredibly slow. And as if we were driving in a car, instead of being able to load balance and put cars through many, many lanes, and therefore traffic is decreased. Okay, so that's an issue with one blockchain and one database. So what's the answer? Well, there are a lot of takes at what an answer is, but regardless of the answer, there has to be three key pieces that come together. One, performance. If you don't have performance and good user experience, people will not use decentralized systems. They will use centralized systems. The other piece is security. If you have great performance with poor security, it's a non-starter. You can't, people will not use insecure systems. The last piece is, which I think has been dramatically undervalued recently, is decentralization. And one of the issues is that these things all pull on each other. They are diametrically opposed. The more decentralized you are, the harder it is to be performant. The more decentralized you are, the harder it is to have security. However, decentralization adds value in so many ways. One, it makes things compliant. If there are smart contracts interacting with each other, it's very different than businesses interacting with each other. And so there's a different framework and rules that you have to play by if you actually really are decentralized. The other piece is it helps networks be less brittle. Centralized networks have very few points of failure, and those points of failure are real. And so decentralized networks have many subtle points of failure that all have to come together to have a real point of failure, therefore creating a dynamic that has not many points of failure. So the decentralization makes networks and systems anti-fragile. I think that's a very critical thing. So let's talk a little bit about the approach of the SKALE network. So we aimed, it was 2017, my co-founder and I, Stan Cladco, we're actually looking at building either a decentralized application. We had a lot of different decentralized application ideas. We were looking at building a decentralized finance platform, and Stan was working on building a DEX. One of the things we realized was we couldn't do that with the current systems, but Stan had ideated and built a framework around how to scale a decentralized exchange and how that could scale the different applications we were talking about. What we realized was this system would be phenomenal, not just for our needs, but servicing other people's needs. And we have backgrounds in enterprise software where we have experience in building software and bringing it to other businesses and people to support their goals. So this approach became the SKALE network. And it's comprised of a few really critical components. One, it's multi-chain. What that means, and I talked earlier about loosely coupled databases that can all speak together in a very, very fast, lightweight, low-cost manner. That's what the SKALE network is with multi-chain. It's a network of limitless application-specific blockchains. It means there's not 100 shards. There's unlimited shards in the SKALE network. And you can think of these as shards. There's a big pool of resources, a big database, and they can be sharded or pooled together into smaller chains. These aren't side chains. Side chains have real security issues. SKALE is a proof of stake network that's built on Ethereum that has an unlimited number of application-specific blockchains. Okay, that brings up the next really critical piece, Ethereum native. Ethereum native, to be Ethereum native as a blockchain, it means you actually have to be built on Ethereum and integrated to Ethereum and have an incentive alignment with Ethereum. And so SKALE, the SKALE token lives on the Ethereum mainnet, and so do many core functions of the network, such as staking. If you want to stake the SKALE network, you have to stake on Ethereum. Slashing, if a validator is malicious, that happens on the Ethereum mainnet. Node assignment. So we talked about the sharding principles and the way that the random selection works and the entropy works for a chain. So let's say a decentralized finance application wants to have $1 billion DeFi application running on SKALE. Well, they can go and ask the Ethereum network for a SKALE chain. And the Ethereum network uses its security properties to guarantee a random selection of nodes, which is really critical for any sharding mechanism. Any blockchain that does sharding uses random selection to ensure there's not collusion, because there's always a subset of nodes that are running the ledger, as opposed to all of them running the ledger, which makes things slower and more expensive. And so the other really critical piece here is SKALE is very dedicated to the success of Ethereum. And that is not just in terms of making EVM the go-to de facto platform and the Ethereum ecosystem, the de facto ecosystem. It goes into an alignment of incentives and money. And so it's actually a revenue share model. So to use SKALE, you must pay in SKALE tokens and also Ethereum gas fees. Anytime you send a SKALE token, you pay the Ethereum mainnet. Anytime you stake in SKALE, you pay the Ethereum mainnet. If you rent a SKALE chain from the SKALE network, you have to pay gas fees to Ethereum in order to pay for the security that backs the SKALE network. So as SKALE grows, so does the revenue back to Ethereum. And that's how real partnerships work that are sustainable and win-wins. And it's really cool to see that happen, not between two businesses, but actually two decentralized networks where there's a revenue share model built in. Okay, and that's also valuable because we support the Ethereum community, and Ethereum developers want to see Ethereum win. And when they use SKALE, they actually don't just pay SKALE, they pay Ethereum, and they pay forward the value of ETH. Okay, all right, next piece here, high performance and full functionality. So on the SKALE network, there are no gas fees. And so what that means is end users come in and they can start using and trading and using the applications, DeFi applications, or beyond that, gaming, B2B, healthcare, it's insurance, et cetera. All of these types of products can use SKALE. And when the users use the SKALE network, they don't pay gas fees. And they do that because the developer or owner of the SKALE chain is able to subsidize that cost by paying in SKALE tokens over a period of time. Now, there's a security mechanism where the developer can implement a gas fee to prevent spamming and DDoSing. But those gas fees then are built on a scarcity model, not a cost model. So you may only have 100 gas units a day, and each transaction might cost 1 gas unit. And if you're trying to spam the chain, you'll run out of that gas really quickly, and you won't be able to perform a malicious attack as an end user. All right. The other piece here that's really critical for DeFi is half-second block time. So when you can run a block time incredibly fast with really fast finality, that means you can make things happen quickly from a trading perspective. You're not having these long times where someone submits a bid and then there's a miner extracted value or validator extracted value where then people can see that and front run the trade, and other mechanisms where people can take advantage of latency. Latency is not a friend to great user experience and fairness. Okay, so the other piece is throughput. Just a large chain can do thousands of transactions per second. Okay, and these are limitless. So you could have 1,000 chains doing 1,000 transactions per second, and it just can keep growing from there. All right. And so that's really critical over time to have a DeFi platform that can grow and service the world's decentralized finance applications. All right, larger block sizes is the next point I want to talk about. So what that means is each time a computation happens, you can get more in the block. And typically for Ethereum and proof of work models, that's good because you can do more per block, more transactions per second. That for scale, what matters with larger block sizes is actually more so doing more with smart contracts. So you can put more into the computation of a smart contract, all right? And just be more impactful with Solidity and virtual machines in terms of doing computation. All right, file storage. The Scale network allows you to store files directly on the network, which is almost as if what you can do with Filecoin and other file storage platforms, you can do that within a Scale chain. All right, the last piece here is machine learning functionality. Because of file storage, there's a component called Scale ML or Scale Machine Learning. And you can put in fraud detection and price prediction, pre-trained algorithms to then, and data sets to be able to incorporate a data point from an oracle and be able to say, actually, based off these dynamics, this smart contract will execute or not execute. And so there's some very cool things you can do here. This is a future platform. It's a next-gen platform. And being able to couple machine learning and smart contract functionality together is really where we're going to start seeing some sci-fi futuristic growth. It's listed last here in terms of the approach because it's something I think will be incredibly valuable over the years. In the short term, we'll see some very interesting use cases, but over time, we're going to see those get even more exciting. Okay, so with the Scale network, we talk a lot about the Web3 Cloud. And so here's Ethereum, one database, and here's the Scale network. But the Scale network is not one other blockchain, proof of stake chain. Like you see from some other solutions, they connect one chain to Ethereum. Scale actually creates many blockchains that can speak to Ethereum, and many blockchains of many sizes, and these are unlimited in quantities. And they can all speak to each other, which is highly valuable in terms of the Web3 cloud and creating the next internet, where all these loosely coupled databases can speak together in less than a second and update state and communicate via messaging protocols, and all communicate back to the Ethereum mainnet. That's what we call it, the Web3 cloud. I talked a little bit earlier about randomness and random entropy. Well, what that means is you have a large pool of nodes and you're able to pull from those nodes. And this is where the Ethereum mainnet comes in, and it helps support that from a security perspective. It also ensures that nodes are rotated intermittently to prevent collusion. Okay, and this is a key principle of sharding. And when we look at Scale, we're really thinking of Scale as a mechanism for sharding, but in an elastic blockchain environment. At the end of the day, we're building a network of app-specific blockchains that can support DeFi and other other verticals. And we have a picture here where these blockchains are all there on demand and can be rented in Scale tokens and via payments to the Ethereum network in conjunction to the Scale. And we have many, many blockchains that are sort of supported by many, many nodes. And many of these nodes actually can support many, many blockchains. You might have a node supporting 30 different applications, or 100 someday when the small chains are released. Another key component for real enterprise-grade scaling is having configuration. What this means is you need to let developers and businesses select the cost model that works for them in terms of, and also functionality in terms of size and features such as privacy. And eventually you'll be able to implement privacy on a Scale chain. And it's all brought together because of the containerized nature of Scale. You can see here, each of these nodes has an architecture where there's a core and there are virtualized subnodes. And the core performs network functions such as orchestration, auditing, and administration. And these other smaller pieces are virtualized subnodes. And you can have smaller chains or medium chains or big chains. And this containerization strategy using Docker is really, the microservices are a requirement for scaling in enterprise. And I'm really excited to see that the Scale team and community has brought this to life in blockchain, which means you get so much more out of every single node. All right, interchain messaging. This is the bridging functionality. And I'm not going to go into too many technical details here because I think I'll try to keep this more at the business level today. But what interchain messaging is, it's a way in a decentralized manner to bridge between Ethereum and Scale chains to Scale chains. And what's really critical about this is that Scale can do this in a decentralized manner. If you look at some other blockchains that work with Ethereum, they have maybe a 5 of 8 multi-sig for that bridge, or other blockchains are entirely centralized on the bridge. And even though they may have some decentralization on the nodes, the bridge is centralized, which means the bridge controls the in and out. On Scale, the bridge is decentralized, and due to the use of consensus and then BLS threshold signatures, and that BLS functionality integrating with the Ethereum mainnet and through IMA, we're able to have a decentralized bridge. What that means is the Ethereum network and the Scale network are each able to lock up assets and have data interacting. And at the end of the day, there's a deposit box and a token manager that work together to essentially freeze tokens on one side, clone them on the other side, and when needed, be able to exit, burn those tokens back, and release them back on the other side. And you can see this code, it's all open source and live on the Scale Network GitHub, if you want to get into the details. But this, I think, is an underspoken narrative in DeFi. I think we're going to start hearing a lot more about not just decentralization of consensus mechanisms, but decentralization of bridges. And I think someone said this on Twitter the other day, and they said, whoever owns the bridge owns you. And I think that's pretty true for all DeFi. And so the goal of Scale is to make sure that the network controls the bridge through decentralization and threshold signatures, not any individual actor. All right, when we think of Scale, the goal here is not to have a finite amount of nodes. It's to be able to have, as demand grows, have nodes grow. That happens through an elastic price curve. And so nodes keep growing, or demand grows, and then guess what? Scale, it gets more valuable. It costs more to run a chain, and therefore more valuable for someone to run a node. And if demand drops, well, the network can scale down as well. It's elastic. Think of a rideshare model, like if you're riding on Uber, Lyft, any sort of decentralized rideshare, the cost for your ride is really dependent on surge. So there's not many drivers out there, well, it costs a lot more. There's a lot of drivers and not many riders, well, you get the base pricing. And that's really how this works. And what it does is it lets the demand keep pace and the supply keep pace with the demand and make it an economic win regardless of the situation. It also helps the network grow so that we don't get to a point where we're just capped and then there's a finite amount of cars and then every ride costs 10 times as much. Then no one drives, everyone walks. And we want to make sure everyone's riding in their own lane in the SKALE network. All right, I'll close here and just kind of give everyone an update. We've been talking a lot about SKALE Summer. What that means is we're at this really exciting point where the network's now been live since October 1st. It's fully decentralized with 150 plus nodes. And there's over $1 billion staked in the SKALE network. And there's a robust ecosystem of partners and projects building on SKALE. And we're going to start seeing the first DeFi applications go live on the new version of the mainnet. There was an upgrade to add even more features. And we're leapfrogging other solutions that are out there. And there's going to be a huge surge of activity this summer. And we're calling it SKALE Summer. So we're pumped for it, excited for this to happen. And the goal is to create an unlimited and expandable universe within SKALE and really help support DeFi. We're here to serve. We're here to support Ethereum. SKALE's community owned, and we welcome all of you to come participate. And you can follow me at holleran on Twitter. And you can find the SKALE network at skale.network. SKALE with a K. It's been a pleasure. Thank you all of you for being here and learning. I know there's a lot of inquisitive people that are really excited about decentralized finance, and it's been my pleasure to talk to you today. Goodbye.